Hi, my dears. Good morning. I welcomes you for the today's session about reflection of light. Let's see what is meant by light. Light is a form of energy which helps us to see the object. To see the object, we need the light. When light falls on object, it reflects the light and the reflected light is reaches to our eyes, then we can see the object. How can you see the object? When light falls on object, it reflects. The reflected light reaches our eyes, then we can see the objects. Light travels in straight line. It travels in straight line and the speed of the light is 3 into 10 to the power of 8 meter per second. This is about the speed of the light. That means 3 into 10 to the power of 8 meter per second. The common phenomena of light are formation of shadows, formation of images, and light is bending, and stars are twinkling, and formation of image rainbow. So because of the light phenomena, shadows, images, stars are twinkling, rainbows are formed. So here, when light is incident on a particular surface and this light will be reflected and reflected light reaches to the eye, then we can easily observe the object. What is the reflection of light? What is meant by reflection of light? When light falls on highly polished surface. What is highly polished surface? Just like a mirror. When light is falls on highly polished mirror and from the highly polished mirror surface the light is sent back to the same media. Then media means medium. The light is sent back to the same medium, then it is called as the reflection of light. When light falls on high polished surface like a mirror, most of the light is sent back into the same medium, This process is called reflection of light. What is that? Reflection of light. Do we have any laws related to the reflection of light? Yes, of course. We have two laws related to the reflection of light. Let's see what are that. The angle of incidence is equal to angle of reflection. The angle of incident is equal to angle of reflection. Now this will be called as the angle, and this angle is called as the incident angle, and this will be reflection ray, and this angle is called as the reflection angle. So the angle of incident is equal to angle of reflection. This is about the first law. Similarly, we have the second law, that is, see, the incident ray, refracted ray, and normal ray all are lie in a same plane. They lie in a same plane. They lie in a same plane. See the picture that we have a surface. So here it is a surface. The light is incident here. Whenever it is incident, is reflected, and this ray is called as a reflector ray, and this ray is called incident ray, and here this angle is called as the incident angle, and this will be called as the reflected angle. So here the incident angle is equal to reflected angle. This is about the first law. That means angle of incident is equal to angle of reflection. Similarly, coming to second law is what? The incident ray, normal ray, and reflected ray lie in a same plane. They are lie in same plane. This is about the second law of reflection of light. What is image? See, image is nothing but when light passing from one medium to another medium through a mirror or through a lens, it will be form images. It will be form images. You can see the figure. What are the characteristics of images? Here I mentioned few of the characteristics related to the images. The first characteristic, image is erect. What is mean by erect? Erect means nothing but straight or strong. Image is erect. The image is same size as the object. Image is at the same distance from the mirror as the object in front of it. So this is about the, so what is that one? The image is at the same distance from the mirror as the object is in front of it. So here that means the image distance we are indicated by symbol V and object distance are indicated by U. So here the image distance from the mirror is equal to object distance from the mirror. That meaning, and coming to the fourth point, so the image is virtual. That means what? This type of the images we are not observing on screen. So those the images which are not predicted on screen, and that images are called as virtual images. Image is laterally inverted. What do you mean by laterally inverted? So this is about the object after passing through the mirror or after viewing through the mirror, and that will be reverse manner, and this reverse manner of the object is called as the inverted. It is inverted. Let's see what is a real image and what is virtual image. So these also are important concept in the coming topics. So, what is real image? When light rays meet at a particular point after reflection from the mirror, the image is formed is called real image. So here this is about the mirror. The light rays are coming from the different sources or different location, and they are after passing from this particular mirror, this light rays are converged are meeting at a particular point. All the light rays are intersect at a particular point. Because of this intersect, whatever image is formed, and that will be called as the real image. Coming to the virtual image, when light rays appear to meet at a defined point after reflection from the mirror, the image is formed which is called virtual image. You can see here, because of the convergence you will get the real image. But here when light rays appear to meet at a defined point after reflection, so here this is quite opposite to this one. So you will see that one a clear image. Here you are not finding clear image, and even though this image is not observed on screen, and this type of the image is nothing but virtual image. So it can be taken on the screen. So the real image you can see on the screen, but virtual image you cannot observe on the screen. These are formed in front of mirrors, because front of mirrors this will be formed, and this is behind the mirror. Real images are formed by the convex lens, because the convex lenses are the sources to form the real images. Most probably the virtual images are formed by the concave mirrors. A real image is always inverted. A real image is always inverted. A virtual image is always erect. Erect means what? This that means lengthy one, straight one, stand up one. And what is the magnifications of the real image? That is about, it is indicating negative sign, and magnification of virtual image indicating the positive side. A real image depends on the position. A real image is depends on the position of object. Virtual image is always magnified. So here real image depends on what factors? It is factors of the object. Let's see what is spherical mirror. Spherical mirror is a curved mirror. What is that one? It is a curved mirror, which is a part of hollow sphere. It is a part of hollow sphere. Spherical mirrors are two types. How many types? The spherical mirrors are two types, and they are concave mirror and convex mirror. Concave mirror and convex mirror. Let's see what is meant by concave mirror. It is a spherical mirror whose reflecting surface is curved inward. Whose reflecting surface is curved inwards. Rays of light parallel to the principal axis after reflection. So here in this concave mirror, concave mirror, if the light rays are passing and these light rays after passing through this mirror, they will be converged at a particular point, and these rays are parallel to the principal axis. This is about the principal axis. Rays of light parallel to the principal axis after reflection, and thereafter the rays will be converge, and this will be converge means what here, intersect, and this will be called as a convergence. So here rays of light parallel to the principal axis after reflection and meet at a point on the principal axis. These rays are meeting at a particular point, and that will be called as the intersect. This is also called as converge, and this property is called as convergence. Coming to the convex mirror, it is a spherical mirror whose reflecting surface is curved outward, that is inward, and this is outward. It is a spherical mirror whose reflecting surface is curved outward. Then, rays of light parallel to the principal axis after reflection, even though the rays of lights the rays of light parallel to the principal axis after reflection, and these rays are diverging means moving into different direction, uh, and it appear to come from a point behind the mirror, and it also appear it's look like the rays are coming from a particular point. You can see the what is concave mirror. See, you will see this is about the concave mirror. Means when you are placing the concave mirror on a board or on a table, you will be identify a little gap, and that will be formed a inner shadow. This is the simple trick to identify concave mirror. You will be get a shadow inside. So in convex mirror, you will not get any type of the shadow. In concave mirror, we will get the shadow. Here you get the shadow, here no shadow. So this is about the inward surface. This is about the outward surface. You take a sole of the slipper, and if you bend inside, and this will be working as a concave. If you bend outside, this will be working as a convex sole of slipper. If you bend inside, inward. If you bend outside, that is outward. Inward is concave, outward is convex. You can see here, and this is about the see the light rays are converging at a particular point, and this is called as a convergence. Here from this particular point, the light is splitting into different direction. The rays are different, so the rays are splitting into different direction, and this is called as a divergence. This is about the convergence. Let's see what are the uses of the concave mirror. See, a concave mirror can be useful in shaving mirrors, head mirrors, ophthalmoscope, that means dentists using, and ENT doctors are using to identify the inner parts of the human body or any other bodies. So here in the shaving mirrors, in the head mirrors, ophthalmoscope and astronomical telescope, headlights. In this device, not only this, there are these I am taking only limited exams here. There are many applications we have with the concave as well as convex mirrors, but I am listing only few of the things here. One is the shaving mirror. That means you can use the when you go to the hair salon, you will be identify the mirrors, and that mirrors will be the uh, concave mirrors, even which we are using our household that to see the faces, and that is also concave mirror. So it will be used in shaving mirrors, head mirrors, ophthalmoscope, astronomical telescope, headlights, and solar surfaces. Coming to the convex mirror. Convex mirrors where we are using. See, in the building to get the attraction, to get the beautiful scenic positions, to get the ventilation atmosphere, we are using certain type of the mirrors, and they will be called as the inside building mirrors. And in vehicles to rear view, we are using these convex mirrors. In magnifying glass, we are using convex mirror. In security purpose, so identification of the in forensic lab, we are using this convex mirror. Most probably not all this one, we are using the application of the convex and concave, both are we are using in our different purpose of studies. So let's see what is the difference between the concave and convex lens. Concave and convex lens. Let's see here. A parallel beam of light falling on this mirror converge at a particular point after reflection. So here, as we discussed earlier, this is the concave mirror. If it is a concave mirror, if the light rays are fall incident on this concave mirror from different sources, and after passing from this mirror, and these light rays are converging, these light rays are converging at a particular point, and that will be called as a reflection. And here all the light rays are converged at one particular point, and this will be called as the convergence. Coming to the concave mirror, the light rays are passing to the same media, or to the passing to the convex mirror. So here what is happening, the when the light rays are passing through the convex mirror, the light rays are splitting, that means diverging into the all direction, and this will be called as the divergence. Coming to the second point, concave mirror also called as convexing mirror, sorry, converging mirror. The concave mirror is also called as converging mirror. Coming to the convex mirror is called as diverging mirror. It will be called as the, so the convex is called diverging mirror, concave is called converging medium. So in concave you will get real focus, that means real images. In convex you will get the virtual focus. The magnification of concave mirror can be greater or equal less than 1. So here the concave mirror magnification is what? Magnification formula is what? V by U. V is what? Object. U is what? Sorry, V is the image. U is the object. V by U. The ratio between image by object is called magnification, and this magnification value is greater than equal or less than 1 or equal to 1. So here the value of magnification, it might be m equal to 1, m equal to minus 1, or m equal to greater than 1. So this will be get. So here not minus 1, less than 1. Now coming to here, in convex mirror, the magnification of convex mirror always less than 1. So this is minus 1, minus 2, or 0. So here this is about the, see here, m value you can take here in concave, that is greater than 1, that means might be 2, might be 2 to anything. Then less than 1, that means you can take 0 0.9, 0 0.8, 0 0.6. Equal to 1 you can take, it might be equal to 1, it might be greater than 2, greater than to 1, it might be 0 0.9, but here in convex mirror it is always less than 1. These mirrors are used as reflectors in projectors, lighthouse headlights, searching lights. So here already we discussed the uses of this one. So coming to here, these mirrors are used as a rear view mirrors in cars and motorcycles, as they enable the driver rider to view the road and vehicle behind. So you can see once again one more diagram related to the concave and convex mirror. So here this is about the reflecting surface for the concave is inward, for the convex is outward. This is about the reflecting surface. So here, and this surface is hard, outside surface is hard for the concave, and for the convex the inside surface is hard. So here this is about the simple diagrams related to the concave and convex. For the concave, the reflecting surface is inward. For the convex, the reflecting surface is outward. Coming to the keywords used in spherical mirrors. So here, the first keyword is about what are the keywords we are going to use in spherical mirrors reflection. That is center of curvature, radius of curvature, pole, principal axis, principal focus after focal length. Let's see what is center of curvature. Center of curvature is the center of the sphere of which the mirror is a part. So here, center of curvature is what? The center of curvature of the sphere with the mirror is a part. You can take this